pray. Dear Heavenly Father, we thank you for this day. Thank you that we are coming to the end of our week. We are finishing our first week of internship. We thank you, Lord. Of recess, I'm sorry. We thank you, Lord. We ask that you shall bless this morning session that we're having with Mr. Geoff as he's giving the lesson, that it will go well. We hope all of us to participate. May we all have power and internet, and may we all be safe. Thank you, Lord. In Jesus' name I prayed. Amen.
Amen. Thank you, Dr. Ruth, for the quick prayer and blessing the day. God should reward you more and live longer. All right. I hope you can hear me. My screen is already on. I've shared my screen. You can confirm in the chat if you can hear me loud and clear by just typing 1 in the chat. If you can see both the screen. If you can't see both, if you can't hear me and you can't see the screen, you can type 2. Then we can get started. I'll look at your feedback. As long as we reach about 10 responses, then you know that it's good to go. So I'm not getting sound. Are you for real? Bless. Are you not getting sound? So how do you type 2 without hearing? Am I audible? Can someone unmute and
yes,
then
you
confirm?
are. I can hear you. Mm-hmm.
Yeah, you can hear me now. The students, the others who are saying, okay.
Maybe they did not log on properly. They did not put on their audio.
Yeah, I think that is it.
Much.
It's much clearer.
Yeah.
Okay, let's get started. Okay, day 3. You know, it's always good to double check. Sometimes you can be, with these online classes, you can be moving blindly and then you leave very many people off track. But today is going to be a beautiful day and it's a simple Friday. I hope you guys have enjoyed the Father's Day, which was on Wednesday. I think it's fun for those ones who have managed to have that opportunity to be with their dad. So today we're going to look at basic operators and expressions. So we shall now cover the input and output operators under this particular basic operators. And we have quite a number of our first project. I thought to do it in week 5, but why not do it today? Since we're dealing with arithmetic operators. So Mr. Livingstone in the afternoon will be handling functions and modules. We have tried to use some of the applications of functions and modules, how to call an argument, how to call a function, which we did it in some few examples, but Livingstone is going to start it today. Probably we'll finish next week on Monday or Tuesday or Wednesday. Yeah, but that's what we will cover. But for me, hopefully, I will finish. I have quite a number of examples here. And I will be just requesting you guys to participate so that we can understand. I want it always to be student-centered. So what are we learning today? This is going to be our subtopic in day 3. It's going to be basic. We'll first get to understand all those operators, the comparison, logical operators, how do we apply them? So we'll have what we call the basic operators, okay, and expressions. So we will also look at input, which I know most of you already know, input and output operations. And then once we are done with that, you guys will be able to, I'll build for you a simple program. Then I will now task you, challenge you one more step. Then I see if you can do it. It's simple, but I think it will be, yeah, it will be somehow mind challenging, but simple. All right. Our first operator that we basically look at it. Let me just make this in quotes, in triple quotes, so that I can write everything here. I can comment it. I can have a multi-line comment. Oh, oops. Okay. One, I think we will look at, first, we'll look at arithmetic operators. Now, under these arithmetic operators, we will be trying to play around with understanding them. Yeah, and of course it's easier. We will not spend a lot of time. Now, just like we have the first one, which is addition. For you, when you're adding any number in Python, you always use the symbol plus, which is for addition. So that is how you can even try to concatenate, join strings and join other strings using, because they have to be under the same format. So you can use addition. So we'll be able to see how we can add numbers. Of course, it's going to be basic, simple. You say, why? Why am I teaching this? Because you're going to use it a lot. And it's better you understand them, which operators are being used in Python. Then we also use the one for subtraction. I've made it easier because now with tab 9, it's just once you, that's why I like VS Code. Once you already have the title, kind of, it will tend to understand, because it's AI driven, it will understand what you're probably looking at. Now we're looking at now the asterisk symbol. The asterisk is used for multiplication. When you want to multiply, always use the asterisk. It's kind of different from the traditional X that people normally use in high school when they're handling, when they've been like in a pure maths class, you use the X, but here it uses the asterisk for multiplication. All right, that's when you want to multiply. When you want to divide, you definitely use, I just want to challenge you a bit. How do you call that symbol? Because I want to know, some people always confuse it. How do you call that symbol for division? You could unmute and tell us.
So forward slash.
A forward slash, okay? So there's a difference between the forward slash and the backward slash. For guys who use Windows operating system, I'm using Linux, so you can see my path, my file path here is a forward slash, but in Windows it's always written in what? Backward slash. So when you're using division, just to remind you, by the way, because you will experience that sometimes people use this a lot. So what does this mean? What does that mean? What does that mean? I believe you guys are seeing my screen. I've put some symbol.
Means a
new line.
A new line. Yeah, so when you want to get a new line, you always use the backward slash and the forward slash. And I think that is it. So as simple as that. Now we can also go one more step when we want to probably return questions without the reminders. So we will also look at that. okay, let's look at the modulus. So we use the percentage to get remainder, okay? Like if you're dividing an odd number with an even number, you'll definitely get a remainder. So you tend to use the percentage symbol for that. There's something which I had wanted to add here. I don't know whether it will pick it up. Okay. This is still divide, okay? You're dividing in Python. But what that double / means is that you return the quotient. I think you understand some bit of pure maths. You return the division, the quotient, without the remainder. If you use double quotes, that means you will return the quotient, which is the division, without the remainder. Am I clear? Then we'll go to the next part, which is going to be exponential. So you'll use the double quotes, the double asterisks to raise a number to a power. If you want to say 3 raised to power 4, then you use the exponentation. So that is what you use in real life. So in practice, we may have to look at this in a simple more example. We can try as many examples as we can to conceptualize this. Then we can get started with also others. But let's look at all of them. So this first part here, which we have looked at, is called arithmetic operators. Now, there's a difference. Now, you see, it's bringing me to what I want. Comparison operators, tab 9, thank you. You're actually making my work very simple. I love tab 9 for that. Teaching becomes much easier. So when you use the double, I'll just press the tab key. When you use the double equal sign, okay, that means you're referring to equals 2. That is when you're dealing with comparison. You want to compare that this is equals to this, x is equals to y. So you use the double comparison operators. Then we also have not equal to. So how do you write the not equal to? I think tab 9 didn't suggest it for us, but as long as you use the exclamation symbol, and then you say, you add a single, I don't know, when you press tab, it will say exclamation not equal to, okay? Not equal to. So that is, but I find it kind of confusing because sometimes you write it like this with a single, sometimes you write it with a single. So you would try to see if you get a challenge with the one which is having the double equal sign, then you can apply the one which is with a single equal sign, refers to, not equals to, okay? So I'll keep this to 2, then I'll keep this to 1, but we'll check it out. Just in case we get an error, we will try to refer to that. But that is the comparison that we use, okay? Then the cool one is greater than. So many times you will try to refer to when you're defining a function, you would always want to see if this is greater than something. So when you're passing that argument and you're calling your function, so you can try to use the symbols. So you use the greater symbol, which is meant for comparison, like this is greater than that, okay? Then less than, you use the less than symbol. Okay. I believe you're trying to note all these operators. And then we can also have greater than or equals to. So when you put the greater and then equals, so you will get what they call the greater than or equals to in our comparison. Then the less or equals to, less than or equals to, you use the less symbol, okay? And then you use less than or equals to. So you use less symbol, this symbol here, equals, that is less than or equals to. So that is when you're carrying out your operators. Yeah, and I think those are all the operators that are there. If I've left out any, you could remind me in the chat that, sir, there's this operator that you have not talked about. So far, so good, right? Now we are going to go to one beautiful one, which is the logical operators. The logical operators. Now, with the logical operators, we use the and, okay? We use the logical and. Let me just put it here. Sorry. We use the logical and, okay? Which we refer it and in most cases, and or. So these are the two logical operators that we use when you are referring to any okay, because when you go to advanced, use the if, but when you try to compare and something, this and, so you use the and. Then we also have the logical or. So the logical and then we have the logical or, which we use the or in quotes. This or that one. So when you're using, then the last one in our logical operators, exactly, tab 9 got me right. We use the logical not. If something is not equating to, then you say not. So what it means is that what is inside the string, the and or, that's how you apply it. You type them in, I know Python is case sensitive, so it would be nice if you always type them in lowercase. And for logical and, you use and in lowercase. Logical or, use or in lowercase. And then you can use the logical not to refer not to something. Okay. All right. Now we will now move to another operator. Nice, Python. My tab 9 is making my work easier. So we now going to see assignment of value. So if you're using, you're declaring a variable and you want to assign it to store a certain value, you've been using this in practice. So to assign a value, assign value. Let me make it get what I need. Just put a quote here. Use equals. Okay. So I believe from there it will start understanding. Now this is what I love about assigning value. So if you're dealing with, you want to declare a variable like x equals to, you want to store maybe age equals to 10 or 20 or 30 or 25. So age, you use the assignment value of equals to assign 20 to age to refer that the variable age is storing a value 20. So age, so we have applied that in real life, but that's how you assign values using the operator equals. Then we also have another one which is suggested here by tab 9, add value. So the add value, if you want to add a value, you can use quote. So you see, like, you can concatenate and then add it with something. So when you're assigning and you want to add something, you can use the add value. Then there's also, you add and assign a value, okay? Add and assign. Yeah, add and assign value. So, right. That's why you have to be in control. This is not right for adding and assigning a value. No. For add, because you're adding is a plus. Yeah, there you go. There you get it. So it's supposed just to be like that. That is when you are adding and assigning a value in Python. So you use plus, then you assign with equals so that it can assign the value. Then you can also subtract and assign a value. So subtract and assign. So it is going to just be a minus equals, that is it. So that is when you're subtracting and assigning a value. Today I see the turn up is low. It's always a Friday. I know why Fridays we have this, but cool. I have the magic how to handle the other 20 or 30 people who are absent. I'll just create the list in the break. And then after that, you register, disable it. That would be fun. So that we know these are the people who have attended. You guys, one thing that you should know is that I'm a data scientist, so I can play around with this data to track your attendance. Remember, you're registering in an Excel file. So tell your friends who have not joined or they have not logged in, for whatever reasons they have, maybe power, internet, they already have the timetable. Dr. Ruth has shared the timetable. Much as I'm teaching what is basic now, you will enjoy it when we are using the actual Python project in using all these examples. You will see how it's beautiful. Introduction always, preambles are always kind of boring, simple because you know them, but we are almost done. We are left with membership operators and identity operators. Then we just go to the real examples, probably play around with advanced examples. That is it. This is not a complex thing, but tell your friends who are not there. Once I create the registration, today, anyway, it will operate within the time we are in class. As soon as it reaches midday, registration stops, because that is what happens in the real lecture room. So, and I know many people have been suggesting that this should be the method of teaching, maybe throughout when the semester resumes. All lecturers have their own ways of, their own approaches of teaching. This is purely for research, and great thanks to Dr. Ruth for aiding the department and getting the right people to help you out. So just remind those people who are not in class, attendance is very important, because I will track and then analyze. I'll use my data visualization. It will show me that you attended on Monday. Remember I use I'll be using an index like your student number, which is unique. There's no way you would figure out how to be in my attendance list, and I will know how you have been attending, and I will assign maybe 5% of your total score on the individual score based on your attendance, and then you see. So better tell those friends to join, and they should always be joining the class. That being said, now we're moving to we've so far finished with subtract and assign. Now we're going to look at multiply and assign. Now we move now a little bit faster because now you already know this. Multiply and assign value. Yeah, that is it for multiply and assign value. You use the asterisk equals to. Then there's also what they call divide and assign. Nice. So for divide and assign, you use this. Somebody mute your mic. Non-term mute. Okay. Then we also have modulus and assign value. So you also use the symbol that, and then we have the exponential and assign value, which you use the double asterisk symbol to assign those values. All right, cool. That is done. Now we look at the membership, how do I call it? Membership operators. So with the membership operators, yeah, you use what they call in for in. Now what the in membership operators in refers, it checks if a value exists in a sequence. Okay, so that's why in, for in, we have used this in for loop. For in, like you look at set in sets, for car in cars. So it checks, that's what they call membership operators. We've been using this sometimes not knowingly, but now you're going to use it knowingly. Like when you're using it in for and while loops. Okay, for. Basically use it a lot in for loops. Okay, so that is what it means. It means, maybe I write it down as a note for you because sometimes you may need to read your note. It checks, this is what I was explaining. It checks if a value exists in a sequence. That is it. Then tab 9, now you get me right. Yeah. Then we also have what we call not. So not in. So the not in operator check if two variables do not refer to the same object. Check if a variable does not exist in a sequence. Not in. Wow. Maybe I need to rewrite this a bit. It's kind of confusing to what I normally know. Tab 9 maybe didn't get what I meant. So because sometimes you can just fill in what is not right. So it's check, not in, check if two variables, okay? Check if, maybe I'm the one confusing it. I think I'm the one confusing it. Yeah. let's go with the latter. That is correct. It checks if value does not exist in a sequence. Sorry, I have a lot of things running in my mind when it comes to this. So that's the right one. It is in the identity operator. The is not. Sorry, I was confusing it with the is not. So the not in operator in the membership operator check if a value does not exist in a sequence. Thank you. I think I needed to trust tab 9 on that. I don't know why I was doubting. So it is in the identity operator. You will see what I was explaining. I think let me first make tab 9 get, I think it got what I mean. Yeah. So this is it. So in the identity operator, it checks if two values are the same, like is. You're trying to check if two values are the same. Is something, is this X is Y. You're trying to check if X is Y, okay? Yeah, thanks tab 9. Tab 9, well done. I think I trust you now. Then is not. That was where I was confusing it with the not in. You know, these kind of words are kind of similar. They're very close to each other. If you're not very careful when explaining, you find you're explaining totally different stuff, meaning something else. But the identity operator is not, check if two values are not the same. Nice, thank you, tab 9, a lot. So these are the basic operators in Python. They allow you to perform a wide range of operations on different data types. You've handled tuples, list, dictionary, and set so many of them, but you can operate all this using tab 9. So I think that was cool. Now, why not dive and look at it with examples? A lot has been said. We look at one part. We look at all these arithmetic operators. That would probably give us on top of an hour. Take a break of 5 minutes, do registration. Then straight jump into comparisons, logical operators, assigned values, use them. Then we go to our final project. I think it will be in the last hour, and you have an assignment that you're going to submit. It would be simple if I said tomorrow by 5 p.m. I think, Doctor, allow me to change a bit. I want to change the deadline to be at midnight today, because when you give them enough time, then they will practice tomorrow. I want to change it because I want to change, the deadline is always midnight. I want to change it so that, yeah, it's much better. Let's change the deadline to midnight so that you can, after the evening class, you get home, you have enough time to practice up to midnight, so that I know by that time, all of you are going home. You don't meet, you don't copy somebody's work and send it to me. Because if I leave you up to tomorrow, you have enough time to go and look for your friend's work, copy it. Just like the way I was marking it, you find the same work is duplicated. And I don't like that. So I'm trying to use nature, time, because after Mr. Livingstone lecture, you guys will be going wherever you're going. So you won't have time to copy your friend's work, so that I can see how you are thinking in a different way. I think we have agreed all deadlines are going to be, yes?
Yes, if they misuse the opportunity we gave them, then we could get back to our strict timelines.
Yeah, they're misusing it because you, like, I've been marking what they submitted yesterday. You find
All right.
Someone copied exactly.
Okay, we shall go back to our strict timelines then. Cynthia, you're not understanding the discussion. Yeah, because they're small exercises, so, and you should all do them by yourself. If you copy, then you miss the learning.
Yeah,
that's why we are being strict. Yeah,
true. Thanks,
okay,
Doctor, for adding a voice. I
yes.
think, yeah, Doctor got me right. And
But
I
maybe
think also, you could explain to them, probably they understand that issue of
Yes.
not doing the work themselves.
Yes, but also we can make maybe the break, it can be 10 minutes, this one, as opposed to 5. 5 is so small.
Okay, 10 minutes.
Yeah, we
okay.
can be doing 10
Noted.
minute breaks.
Okay.
Yeah, okay.
Okay, thank you. We are improving, by the way. I think that's why doctor is always there to make sure that quality. We want to make sure that when you guys leave the university, you should be proud that yes, Dr. Ruth chaired our research, and indeed we have learned a lot. You wait when we reach machine learning, and I'm going to use my master project to help you do machine learning. So I'm going to use, and we have to start it earlier because we are going to create our own data sets. Because
Wow.
the problem, yeah, we want to create our own data sets because mine was dealing with fingerprints. So they will use their own fingerprints in the machine learning. So, and then
sounds
first,
exciting.
yeah, it is. It is. I did it during my master. So it's very fun when playing around with those algorithms. Okay. So now let's go to examples and we have a lot of fun here. So I'll try to write all because you've tried most of them out. So let's just play around with them faster in terms of the logic. Okay. I think they're all here. I could just copy all this. These are just examples. Just have to hash this. Examples of arithmetic operators. You've used them a lot, so I just want to give you enough examples. Okay, just give me some second. I first comment this because just want to have examples on it. Just have to one. Okay. Thank you, Pretty Formatter, for formatting that. Now we will now look at it in real example because we have now done how to assign value. You know it. So let's say let's say we want to add. So what are we adding? Let's say x is a variable. So we are adding, okay, 50 plus 45. 45. Okay, 45. Now, this is how we are applying it. We variable x equals to, we are referring it will add this 50 plus this, you get the answer just in a simple way. So if you want to get the output, you just print x. Okay, I don't need to try this in my terminal. Okay, maybe I'll try it once, then you guys will proceed with the rest. Print what do you say? Print. Okay, we are running it in the terminal. Print Geoff underscore Geoff.py. We're just running it. I just encourage you to always use the terminal. So you can see the output here. It's 95 for adding. So definitely it is correct. But now in our next program that we are building, we are going to build an actual calculator. I just have to maybe give you a glimpse of what we're going to have. So we're going to have an actual calculator, but your assignment will be with the GUI interface, a calculator with GUI interface, which you have built using Python. It's fun. I think that's what you've been doing it in other programming languages like C, C#, I don't know what, maybe Laravel. Any, we could do that. Then for now, this makes it easier. I know I want to be a lazy kind of a student. So I'll just print this throughout. Then we shall just change the symbols. Then when you run, you would see okay. I think that solves all the puzzle that we have. But what I think might be a problem is that we are going to confuse our program, because if we keep using x, Python will just say, I don't know what you are now referring to. There are very many x you have declared x in. So let's just try to change. Should we say x, y? Yeah, x, y. Okay, we will be changing. So y, for subtraction, you just put that. I think that's simple, right? I don't need to over explain. You guys now know. If you don't know, probably you let us know. Z, multiplication. I said it is asterisk. Z. Okay. Be careful with some keywords. Let's just come back to A. We are dividing. Then B. Oh, we say that when you don't want it like that twice, okay. Then BC. C, that's a modular. We use the what? Okay. I don't know, but that's what we'll try to see the remainder which are there. Maybe to make it easier, some make it match the one that it's easier to interpret. CD, exponential. Okay, like 2 raise, say double, raised to power 4. Then what you're printing, make sure you also change. Here you're printing D. Here you're printing C. Here you're printing B. Here you're printing A. Here you're printing. Here you're printing Z. Here you're printing Y. That is it. Okay. You save. Let's run and see if we'll just probably we might need a text. We might need a text to separate them. Let's first see the output here. Okay. Okay. Okay, the output is fine because when you add, you get 95. Okay. Okay. Yeah, that is it. You just know that the first one belongs to addition. When you're adding, when you're subtracting, you get 50 minus 45, you get 5. Then when you're multiplying 50 by that, you get 2,250. When you, yeah, I think that is it. So try it out and share your screen Only 3, okay. 5 people share your screen. Let's see what you've done with these operators. Then we shall have a break after people sharing the screen. Let me know what you think. Share your screen. I hope it has been simple and I've not used too many words to explain. That's what I'm trying to avoid. Okay. Proceed. You could unmute and explain what you've done.
So I did some addition here, and you can see my output would be 100. Then I did subtraction of 280 minus 63, and my answer is 217. Then I also did a multiplication as an exponentiation. Yeah, and this is my output.
Okay, thank you. Well done, Prosi. We're lucky that this time round is a lady sharing first.
Welcome.
Next, probably about 5 more people. Just to see if you're following anyway. This is it. You unmute, you explain. Catherine. Natukunda. Are you able to unmute, Catherine? Okay, Catherine. She cannot. No. Okay, we have seen. Next person. Student-centered. Yeah, exactly. Student-centered. That's why we are giving you now your opportunity to share what you've done.
Is basically what I've done are the arithmetic operators: addition, subtraction, multiplication, division, and the output is here. Thank you.
Thank you, Katho. Next. Anthony. There are people who have never shared their screen and they're here in class. You guys, how do you feel?
Yeah,
Yes,
so
Anthony?
here I have x and y, and the addition says x plus y, and the output gives me 7, as you can see this side in my global frame. And then multiplication, I mean subtraction, it's the same, gives me 3 when I output that. Yeah, and the rest of the arithmetic operators, that's what they give me in the output.
Okay, thank you. Anthony.
Yes, please.
I noticed you using another extension for the display. Which extension is that?
It's a preview extension for Python.
Okay. Maybe for those, anyway, we shall see, but we shall see when we reach data science if some of those can, but still it's having that inbuilt extension. Okay, that's unique. Nice. Abdallah, for you first, wait.
This is
You will explain this one.
Abdallah.
Abdallah, you will come later. You'll come later. You would come later. I see.
Okay.
I see you're ahead of other colleagues. Okay, so we're going to go for registration as people explain. Then we shall go for a break. We shall resume at 10:10. Let me create the form, but feel free to share your screen, explain as I create the form. student registration. Can that person, this person is annoying. Can you?
Okay, I'm Joshua Coney, and this is what I've done so far. I just did addition, subtraction, division, yeah, and this is my output. Yeah.
Whoever is sharing the screen, can you unmute? Also, Geoffrey unmuted you.
Okay, yeah. I've unmuted. I'm just creating the form, so it's going to be quick, but you can share your screen and explain. But we are in a break as we wait for the link for registration. Okay, welcome back from the short break. I really appreciate because registration has been done perfectly. 118 have so far attended. Much as you log in, log out. So I don't know the logic. Anyway, we will still get those people who are dodging, and later we shall reward them very well when the course ends, when the recess ends. Yeah. I think I want to use today to get the actual number of students. So make sure everyone registers before midday. I will leave the link open up to midday. Okay, back to our examples. So we're just playing around with examples on what we have so far handled. Then we shall do our last assignment in form of a simple program. But for now, let's move to comparisons. Now, the concept is quite simple with comparison. We have explained it. But I just want us to use a simple example here that I think can let us play around with all the comparisons that we have learned. Let's say okay, I'm thinking, but just let's use A equals 2. We can get since we are comparing, we can get a number like 15 for A, and we can get a number for B to be not 20. Let's do 9. One thing that you'll notice is that all these are odd numbers. I've not tried. We shall keep trying. Can change it to have it an equal number. So let's begin with our first thing that we talked about, greater than. So how do you apply? Okay, this is kind of advanced. This is now using if. Okay, let's first run and see its output. If it's okay, we can. A is greater than B. Okay, cool. Let's use that then. So here we are using if. So if A is greater than B, then our result is going to be you print A is greater than B. That's one way of doing it. Then two, we can also print, can actually print. We can try to print logically and see. What if we say A is greater than B? Do you know what happens when you run this? Do you know what happens when you run this? I think, let me print it. Of course, it gives you like, is A greater than B? Yes, A is greater than B. That means it should print true. That's what I'm thinking. True. Yeah, okay. So we'll use this kind of example throughout. So we shall use the if and then we test it. All right. So that's one way. Thanks tab9 for suggesting what we should do. If B is less than that. Yeah. So that means A is less than B. This is kind of elaborate. So that means we're using that to print B is less than that. We can go over this faster. Then because we're using tab 9, so it's not, so we can use greater than or equals, or greater than or equals 2. If, okay, so for greater than or equals 2, less than or equals 2, if tab, thanks tab 9, you've actually simplified the writing of the code. Greater than or, now let's do equals 2. Equals 2. If, nice, then not equals 2. Nice. You guys, you should install tab 9. Eh? Just imagine how much time we are saving. I'm actually enjoying all this stuff now. But if we were using our traditional PyCharm, you guys you'll be getting annoyed every time you have not formatted it. Here, we have the pretty formatter. This one down here, it's doing a good job formatting the codes for us. And tab 9, which is just an extension, it's just making our work very simple and kind of making we can learn very fast. I think that's the reason why we are moving this time very fast. I was wondering, why are we moving so fast? Because we're not spending a lot of time writing the codes. So it's just suggesting what we need and we are in control of what we want. Okay, so this is a simple explanation for greater than. So we have 2. You can double check here. A is equals to 15, B is equals to that, greater than. If A is greater than that, print this. So we can double check it also. It print A greater this, A variable. So A is literally greater than B. So in a similar way, explain all this And for greater than or equals to, if A is greater or equals to, is A greater or equals to B? I think the results here will be false. So this is now what I need to get from you logically, because is A greater or equals to B? What is going to be the output? True or false? I think we can apply that. Now I'm asking class, is A greater than B? Is A greater or equals to B? What do you expect in the output? Is it a true or false? In this example here, greater than. Is A greater or equals to B? Okay, the answer is false. Is A greater or equals to B? The answer is true. That is, so A is greater than B. Then is A less or equals to B? The answer is false. A is not. Okay, so let's run the output and see it in the terminal. So you can see most of this stuff, A is greater than B. A is, that's true. I wanted the false scenario. I wanted false scenario. So that means I have to change it like that. So is if A is less or equals to B, print. But of course, definitely A is not equals to, is not less than B. Okay, let's check it out in the, no, I've not explained it well, but I'll give you a chance to explain. Wanted a false scenario. All of them are true. Okay, I can just write it here myself to get a false scenario. I want to have a situation where I have a false scenario. This one suggested by tab 9 is not trying to explain what I want to. Let me just make it simple. Let's try to see. Okay, let's done. Okay, let's done or equals 2. Now I just want it to, I'm not going to use if round, I'm just going to print straight away. I want to print a situation where I know very well that B is not less than A. So I just want it to print, is A less or equals to B? Now we can double check this argument out. We want it to print in terms of true or false. Is A less or equals to B? No, A is greater than B. Now I've explained it very well. So the answer here is false, okay? So let's save it and run that last line. This is the one which I'm interested in. So you can see the last one is false. A is not less than B. It's not less or equals to B. So you can play around with that kind of logic, and then understand the comparison. We dealt with a situation where it's true. Let me also try it one more time. That one I tried it when it is less than. let me try it with greater than or equals. No, let me try it with equals to. Equal to. Okay. So let's see. Yeah, that is it. I think it's getting now what I want. Equals to. Yeah. You just ask yourself, is A equals to, just look, is A is 15. Is A equals to B? No. A is 15, B is 9. So that's how you look at the comparison. So when you run this output, what you expect is a false, because A is definitely not 15. Yeah, I've explained it now very well. I think you have understood. Let me clear this screen. Okay. Then I'll give an opportunity to 1 or 2 people to explain it. You can pick one kind of comparison that you want to explain. You don't need to explain everything. Okay. All right. Yeah, false. So you can see it here. So definitely A is not that. Okay, pick one comparison that you want to explain. I'll stop sharing the screen for 1 or 2 people, a boy, maybe a girl and a boy. And then we proceed with the next part. So let me stop. Let me stop sharing it, the screen. Just pick one, which is not, it's giving us a false, which the output is false, using the different comparisons that you have learned. Just pick one and display your screen, explain it, and we see the comparison, how you are able to apply comparison. So Ogik Moses is a guy, is a boy. So the next one we expect a lady to explain. Unmute
Yes,
and explain. Good morning.
Yeah, I'm going to explain less than. You realize our A is 10 and our B is equal to 55. So if you come here and you say if A is less than B, print A is less than B. But you realize A is not less than B. It's not what? A is less than B, but here you're saying you print A is greater than B, yet our A is less than B. So it will print false as the way of saying it here.
Okay, nice one. Now you've got the concept. A lady, then we should be able to proceed to another thing. One lady, then we go to logical operators.
Hello.
Hello.
This is Catherine Atkonda. I'm going to do the not equal to. So I have my y as 10 and my z as 35. Then I put a condition. If y is not equal to z, I print false, else I print true. So if I run and I'm going to print, it's false because y is not equal to z.
Okay, thank you, Nachukunda, Catherine. Now stop sharing, back to me. Okay. Okay. That was well explained. Yeah. So we're using the student-centered approach. That's why I'm giving you opportunity to explain. And I think we are moving very well. I want you guys in future to remember that we laid a very good foundation for Python and you're able to get jobs. Because many times I keep reminding you that there's going to be a lot of unemployment because of AI, where you need 10 workers, probably you may only need 3. It's going to happen a lot. I think this is something that the government will, but it's going to happen a lot with AI. Just trust me, AI is going to replace so many people whose work were just basically trying to solve simple, basic problems. Now imagine if you are not very good at writing programs, you can be replaced. Tab 9 is doing it. So you find one guy who needed to look for, get ideas or solution from one person. There's BARD, there's ChatGPT, there are very many AI tools. So literally people are going to buy robots at their home. They would, instead of asking, they will be asking the robots, their personal assistants. So even with maids may even phase out. We have even robots which are maids. Those are things that I see as a threat to employment. So it's better you understand the things so that you can be employable. That's why research is there for you. So now let's look at logical operators. Now in this example, we will try to use the and, or, and not to perform. Okay, let's first have the title. Probably I might be confusing people here. Logical examples. Of course, these are just examples because we have already we've already looked at it. So examples with logical operators. So why I always try as much as possible to put to comment first. Tab 9 will understand what I want to do. Now knows that the examples that I want to apply here is just going to deal with logical operators. I even make it much easier for it to always recall what I'm doing by say, yeah, I'm just dealing with logical operators. So let's keep it simple. We've been using A, so we still maintain that. A equals to true, and then B equals to false. Now we're going to use the first logical operator AND. Now what the logical operator AND here means, we want to see whether A and B, whether A, we are using AND to see if A and B they mean the same. Okay, they represent true. So in our console, we will be able to try to see the output. So when we use and we say if A and B both are true. So let's check it out and see. Remember, I have this part of the code which is not commented out. I can comment it out so that I can have the output of only this last part here. So what do you expect in the second line? Print A and B. When you print A and B, both are true. If A and B, print both A and both are true. Okay, let's first run this and see. Oh, nothing happens. Let me not use this. It might confuse what I meant. Okay. Okay, just don't use the if for this particular part. Just print A and B. It's what I'm interested in. I would just want to see, because when you use if, looks like the kind of output I don't get. Okay, because here what we are trying to, in this example of the logical operators, because we know A is true, A is declared as true, B is false. And if you say our logical, you're trying to say print A and B. Is A and B, are they of the same variables? So when you print, logically, it will know that A and B are not in the same, they're not in the same what? Variables, okay? That's why it returns it as false. It displays the output false. So let's try it one more time with logical OR, and we see, we just print. Then I will explain to you. Okay. So with the OR, either A or B, so it doesn't care. That's why you'll find its output is going to be true. You're trying to print either A or B. Either it is true or it's false. So you find it giving us true. So let's run that and print and see. So it is in the second one, it's true. And then the last one is the logical NOT. Logical NOT. Now with logical NOT, when you print, you just say not A. So if it is not A, then what do you expect? False. Not A, false. Not B, true. So you understand, eh? When they say if it is not A, then it's false. That's the output. If it is not B, then it's true. Yeah, we can actually have it both. Not just Control Z, clear. Print. No, we are dealing with logical NOT. And in the logical NOT, not A, then in the next print, not B. Yeah, that's what I wanted. I just wanted it to print for me, not if it is. Now we look at it in this example. If you are saying it is not B, the output should be what? True. No, if it is not B, it is true. If it is not A, it's false. If it is not B, it is true. If it is not A, it is false. That's the output we expect. Okay. Okay, so you can see in the last one. So print not A. So not A is false. Print not B. B is true. So that is how you apply the logical operators. Then we can now look at one more example in assigning values. Okay. In assigning values in assignment of operators in Python. Then we can finish up that, then you can proceed. I feel like can someone try to share the screen and try to explain this concept? I feel like maybe people might have not picked the concept. Let maybe one person share the screen. But to me, it's quite clear. Probably you would hear from your colleague. Yes, Brian? Brian, can you unmute? Oh, okay, you've unmuted. Can you explain? What's Brian doing? Brian, who is this? Mulindwa. You're not explaining anything here. And I see you having a syntax error. Why are you using logical and? Brian, I'm not using Windows, so please you should try to debug your problem out of the screen. Brian, could you stop sharing because you're consuming my time? Remember, I'm now going towards this time, and I want to finish this because when I'm done with this, we can now look at the other project. Time is Brian getting me?
Yes, I'm getting you.
What's your problem?
I've solved.
You've solved, eh? Okay, you explain.
If A is a Boolean and it's true, while B is a Boolean and it's false, the result will only be false if any of the conditions is false. So if you're having B which is false and we're trying to say A and B, the result is going to be false. Well, if both are true, now if you try here, if you try to run this, you see the result here is false. That's because one of the conditions, which is B, is false. But if one of the conditions is true, I mean both the conditions are true, you are going to have here true. That is for and. Now, if you go to logical or, for or, one of the conditions has to be true for the result, the output to be true. So it only requires one to be true such that the output is true. That is, if you have now this as false, A is already true. A is already true. So if you are to say O of B, the output here is going to be true, as you can see. Now, if you go to, there is also logical not. If you print not A, it's like you are negating A. For example, if I say I'm drinking porridge, that is now true. But if you say I'm not drinking porridge, now you are trying to negate, and that will be a false. So this one is supposed to print a false statement if you run it. Sorry, not A is initially false. So it's like I'm not drinking porridge, but then when you negate it, I'm drinking porridge. So that will be a true statement. Then I think I can stop there. There's also the bitwise operators, but I think Master will look at it.
Okay.
Thank you, sir. I'm sorry, earlier I had a notice that it was muted.
Okay. You know, I'm so much concerned about time, because
Yes.
if we use our time effectively, we do not lose anything. Please type in the chat one if everything is now clear. Just type one if you have understood. If you have a challenge, probably type two. Is this guy going to explain? There's some guy there. Someone is sharing the screen. Oh, okay, I think they stopped. Someone is still sharing the screen. Emmanuel, are you done? Okay, I've just seen something in the chat, which I'm going to address it before we jump to our example. Let me see. In the example, Trevor said that bitwise operator, sir. I'm going to talk about it. Yeah, I'll talk about all these operators. There's nothing I'm going to leave. That's why this time I'm following what is in the chat. I don't want to ignore any message. Bitwise operator, I'm going to explain it. Okay. Yeah, I think that's the only thing. Doctor can confirm if there's anything that the students are raising, but I only see the bitwise operator, which I'm going to explain in our example, because I have it in this part of I didn't explain it in the previous part, but I'm going to explain it.
Yeah, there's nothing else, Godfrey.
Okay, if there's nothing else in the chat, that means that's much fun. So let's now, because we are explaining all these concepts and we don't want to miss anything. Okay. All right, so let's look at okay, assignment operators. Not so? Let's try to deal with assignment operators. Assignment operator. Okay, so we of course we have explained that if you're using assign, you just get a variable, then assign it some value using the plus. Then it will add something. Of course, tab 9 is going to even suggest for us something here, which is going to be cool. But let me try to hash all this, comment this out, so that I do not have this again running. When I'm okay. All right, so let me explain assignment operator. I hope we will have enough time to do our project, our assignment project. I will try to be faster. Is that okay? Because these are simple concepts. Now I'm going to begin with what they call compound assignment operators. Compound assignment operator. Okay, there are many. Let's just call them assignment operators. Now, we're just going to play with one example here, like A is 5. I don't want to make it much more, like kind of complex. So we already have, we have assigned A equals to 5, storing an integer 5. Now what we are doing here is we are adding A plus, we are assigning a value. Then you want to see its output. So A and assign. So we want to have A and then assign something. Now let's say we're saying we are A, okay? A is already, we want to add. That's why you see, we just press now tab, because we want to add A plus another 5. That means that the output, A is already what? A is 5. So when you're adding A, plus equals to, that helps to assign a value. That means the result is going to be what? 10. Let's save this and then run it in the terminal. Hope I've explained it well. So that you see now we get 10 because A is 5. We have assigned A variable is storing 5. When you hover over A, you see A is a variable that is literally storing 5, which is an integer. So when you add this, you get what we call, it prints the summation, which is, so you can assign value. So we have done it with A, we are adding. We also mentioned that you can subtract and assign, okay? Now let's also have that example faster. I'm going to move a little bit faster. Forgive me because I feel like I've used a lot of my time and I feel like I want to have time for my assignment, because now for subtracting, let's try to increase the value here to maybe 19. Now A minus 5, then print A. We will have a lot of problems. Remember what I said, that whenever you use A, it's going to confuse Python. So we could change this to B, and we have it as what? We can have it as B. Okay, and we can have it as B instead of calling it A, B. Now that means we need to, okay, we need to just change here that that our B is actually 19, okay? Then when you subtract that, you get 14. So you print B. Let's do that and let's run it. Yeah, you get 14. Just notice that there are some changes with the first one because we changed the value of A. So in the second line, you see you have signed B 19, and then B, with B you adding that, you're having variable B minus that, then you print B. So that is how you can deal with assignment operators using compound operators. So you can also try it with multiply and then divide. Okay, you can try it out with all this just to confirm. That means when you're multiplying and assigning, also you just need to get a number which you're going to, so multiply that, save it. When you run, it should be able to multiply with the value you're assigning. So this time that gives you 95. I think this is quite easier. It's explaining the concept very well. You can also apply it for divide, for division, divide and assign. So you can have probably D and then you divide, then okay. Up a bit, let's clear up of the screen. Okay. We run it in a terminal. Okay, 19 divided by that, you get that with the remainder. Okay. So that's one cool thing with the divide bit of it. So you can also do it with what else have we left out? Modules and assign. So let's say we have E, then can save it, get the remainder, because you are assign E and then you're trying to assign a value. The assignment is just this part, okay? Which you use this symbol here, the module and equals to assign. Then you run, which you get a 4, okay? No, yeah, you get a 4 when you, because literally what remains, remainder. So you get 4 when you subtract that. Then we can have the last bit of it, which is going to be exponential. which we can have exponential and a sign. So we can have like f. This time round, let's play around with a small figure so that it's not exponential. To raise it to 4, then we could print f. Then we'll get the, let's up a bit. Okay. Then we will have it when you raise 2, raised to power 4, you get 16. You could double check it yourself, whether it's giving you the right stuff, but that is it. It's definitely correct. So basically, you've seen that when you're dealing with compound assignment, you can perform and assign the task and then get the results of the variables that can easily be updated with the corresponding assignments that you have added in the operator. And then the results that we'll be able to see, it's what we have been printing it in the terminal. Yeah, so that is it. So let's go and look at the last bit of example. Then we look at membership operators, then we look at bitwise, which I'm going to explain. And we jump for a break. Then after the break, we can come back and yeah, after the break, I think we might go for a break. Then yeah, we're likely to go for a break, then come back and finish bitwise operators. So let me finish this remaining part, which is it's called members, which we have done it. Membership assignment operators. So with membership assignment operators, just like I said, you can use like in, not in. So it helps to check if a value exists in a sequence. Now this sequence, probably we can let's have a membership operators with cars. Let's have a membership operators with cars. So let's see. I think we can have cars. Then which cars can you think of? Our car A can be a Jeep. Then car B can be a Tesla. Then car C can be what? A BMW. Then a Rolls Royce. Is that the Rolls Royce we know? Rolls Royce, okay. If that is it, I've never owned those cars, so just forgive me. All right. So now we can say print, just like I said, you can use it if Jeep in cars, print Jeep is in the list. So it just helps to check if Jeep is in the list. And then we can also check it. This is just use if. Alternatively, you could print it and just confirm if Jeep is in the list. You just check if a value exists in a sequence. We have a sequence of cars. So we want to check if Tesla is in that sequence. Let's print check. Print. So what we're using here, I'm just going to write everything in the output. So I just want to check Tesla. Is Tesla in the list. So if Tesla is in the list, it should return true because Tesla is in the list. Now, then if Tesla is not in the list, let's try to print something which is not in the list. We have printed BMW, so let's print Toyota here. Toyota. So let's check our list. Are you sure Toyota is here? It will return false because Toyota is not in the list. That's how they call membership assignment operators. That is it. Let me save it here, and I've explained it very well. So you see Toyota is in the list. Toyota is not in the list. Toyota is not in the list. So we just have to say Toyota is not. Toyota is not in the list. Oh, I've remembered. I think my quote is the one which has made it match. Let's just change this to, okay. Guys, allow me to rewrite this because I'm not getting it the way okay, let's just improve this code. We're just going to say Tesla. We're just checking if Tesla is in the list. Just say Tesla in what? Because we just created a variable cars. We are not interested to know the position yet. Okay. Tesla in cars. We just want to check if Tesla is cars. And then we also want to check if Toyota, you know, tab 9 can also disorganize you when you don't know, because you just feel like the text is generating is correct. We are checking if Tesla is in cars. So my expectation was, because we have Tesla in the cars, it should be true. Then Toyota is not in the car, we should expect false. So that's what I expected it in the terminal. Yeah, okay. This is it. This is what I'm explaining. So Jeep is actually in the list. No, Tesla is in the list of cars. So we are checking that if Tesla is in the list of cars, and that's true. But Toyota is not. That's why we see false. Toyota is not in the list of cars. So that's what they call membership operators with not and in. Now, our next part of it, you could try, I've already explained with you using this example before, because I see, okay, let's jump for a break. I'll come back and explain, I'll explain now the identity operators and bitwise operators, then we look at one example. So I'm sorry, I'm going to reduce the break to 8 minutes because I've entered the time. And you guys are saying that we should reduce it to what? To 2 hours. Don't you see now 2 hours is not even enough? So I think Doctor can stop recording a bit as we jump for the break. Then of about 8 minutes, then we come explain identity operators, bitwise operators. Then I do the program. Then I give you the assignment. Yeah, I think it will be on top of the hour. Thank you. If there's any question, throw it in the chat. I'll check it out as you go for a break. So just head over for a break. We shall resume with identity operators. Okay, it's 10, it's 11:10. Because we're likely to run out of time. So I'm requesting you to get back and we proceed, because we're likely to, we are left with only two concepts. We are left with identity operator and bitwise operators. These are the only thing we are left with under the operators. So once we are done with that, it's going to be easier to now do our, then we shall have our example and assignment. So these are the things we are left with for today. So let's get started and we finish it. All right. I hope everyone is now back. I see 103. I've logged in class. The good thing, we can see attendance in real time. For those ones who have logged out, please log back quickly. And I can share my forms again. You can see we have 113 responses. I think this is good enough. Why not we stop accepting responses now? So whoever has not registered has not registered. So we can take this to Excel, and Excel will definitely show all your time of registration, your full name, your student number. Now look at this person here, Edgar. The registration number, you're doing the opposite. Then some student number are longer. You end up I don't know. Okay. Anyway, I'll try to match this registration number with the other 3 attendants. Then I'll get a graph of what you've been doing. Okay. That is that. Let's move to identity operators. Now with the identity operators, we tend to compare the identity of the objects. Like if we have assigned variables for 2. Okay, let's just do it practically. Like X is lambda and Y, no. And Y is lambda, okay? Now, we just want to use identical operators. And you know, identical operators, as I said, is simple. We use what they call is operator. So the is operator is the one that helps us to understand. And it can go on and on. So I press tab. Now that is good. So now, so print is, okay. Let's do it here. Print X is Y. You check. Definitely that is true. Because X equals to lambda. Y equals to lambda. Now X is Y because the what is being stored is the same. So when you save it and run, you will get almost everything true, because it will all be true, because X is equals to lambda. Okay. I'm just getting an invalid syntax error. What if I tried? Okay, let me. I don't want to have problem. Let me just change it to an integer. It has stopped complaining. So you can see in our explanation here. So in our first operator is x is y. That's true. X is not y. That's false. X is y. That's very true. And then x, then we are using equals. X is equals to that. So you check. You get what? True, because x is equals to 10. X is 10, y is 10. So they're the same. That's why you get true. Then you move to the next one. X is, we're using the exclamation. X is not. So this is how you apply the different operators. But I was interested in this first two, x is y or x is not y, to explain this. But you can explore this. We already covered them with the exclamation. Now we can also try to check it out in form of like if you're dealing with list. Okay, let's say we have we did x, so we can do a list of a list. Let's just do a list. That is fine. Then also we do a list of w, not while. So we have the same values here. Now what I just want to check here is to print. Let's try to use the is not operator here. So what I'm trying to say here, if you look at, I didn't close this, that's why it's complaining, solved. Let's look at this. We are trying to see our Z and W, the list are the same. Now, when you try to print using the is not, and we want to print to see if Z is not W. If it is not W, it tells us false. If it is W, it tells us true. So of course, Z is W. When we save it, and I comment all this out. I have to comment this out. So that I remain with that example. Okay, so what it means here when you run false, when you say Z is W, Z is W, it's giving us false. Now when you say Z is not W, Z is not W. Let's see. We get true. We get true because Z, the lists which are in Z are the same. That's why we get true. Okay. But Z is W, we get false. So I don't understand why it's giving us Z is W as false. Z is W is false. Z, okay, Z cannot be W. The variables, okay, it's meaning the variable Z cannot be the variable W. That's why it's giving us false. That's how I'm understanding it. And I believe it's true. Then Z, the value, the list which is in Z equals W is not. We're trying to compare what is not. We're trying to compare if this list here is not the same as that list, which is giving us what? True. Because it is. Okay, so that's how you deal with identity operators. Now, what you need to understand is that we have a list which we have had here, the list for Z and the list for W. That contains this integer. Now, these values here in the list identifies if it is not the same with the object in W. That's why you see the result is returned true. Okay, so now we're going to move to our next part of the last bit of it. It's 21. We're going to move to the bitwise. We're going to move to bitwise operator. Then I'll do the assignment using one way. Then I'll allow you to do the practical assignment, which the submission is going to be at midnight. Okay, so with bitwise, first of all, bit is for binary. So bits of binary numbers. That's what we refer to. So just to explain it much better, I'm first going to use the triple quotes to explain everything here. I'm going to be a little bit faster because we have consumed our time, and let's see. So with the bitwise operator, actually bitwise operator, even when you keep like saying I use to perform operations on individual bits of binary numbers. Yeah, so that's what bitwise operators means. Now here we will have let's see, we'll have what they call bitwise AND. I know it will be suggesting for me because bitwise AND. Now the bitwise AND, it's normally represented with a symbol AND. Okay. Now what does it do to understand? Now this performs a bitwise AND operation, okay, between let's say between not two, but between the corresponding bits of two numbers. Okay, I think that is it. We could have even shortened it. And these numbers could be, yeah, two integers. It's okay. Now, let's say that we have 10. How is 10 being represented in a binary form? So we'll try to look at an example of how we can deal with that. But here, the result, if both bits are 1, otherwise it will be 0. That's how we deal with it in real examples. So 10, you know, computer stores information in form of binary bits, 0 and 1s. So we'll see if it is 1 or both are 1, or otherwise it is what? 0. We'll try to look at a simple 1 or 2 example. Then we'll go to our assignment, balance up the time, and we could do that. So that is 1 when you're using the bitwise AND. Then I just press tab because I know it has understood that I was explaining the bitwise and oh, right. I forgot to put the closing stuff here. It didn't complain because it's commented. It's in a multi-comment. So the bitwise or we use I performs a bitwise operation corresponding bits of two integers. Okay, or numbers. Numbers are integers. Nice. So and this time round, if at least one of the bits is 1, then the other one is otherwise. If at least one of the bit is 1 and then 1 is otherwise. So that means supposed to have 1, 0, 1, 0 otherwise. Yeah. So that's what the bitwise OR operators does. Then we also have the bitwise XOR, which is X is for exclusive. Bitwise X for exclusive. Okay, exclusive OR. Now you see the exclusive OR uses this. How do you call this symbol here? Someone help me unmute this symbol here, the one I've highlighted only. Unmute and explain for me that if you know it. Unmute and explain that symbol. Is it like the upper? Okay, but it performs what they call the OR operations. Okay. Now, which the OR operation means, it shows that the corresponding bits of two numbers. Then we also have the bitwise NOT. Bitwise NOT, which is sometimes, I don't know, can we use the symbol here? Because tab 9 is still thinking that symbol NOT. Just try, I think I've kind of forgotten these symbols a bit, but just help me type them in the chat. This symbol here, how it is called, and this one here. I need to check back those symbols once again. I've taken time without playing around with it. I use them frequently, but I think their meanings have disappeared from my, how they call them. All right, so, but that flips the bits of numbers like 1 to 0 or 0 to 1. So when you use it, it flips the bits of the numbers. So when you like 1, 0, and you want it to be 0, 1, so you can flip it using the bitwise NOT. Then we also have yeah, I love tab 9. The bitwise left shift, the one with the double less than signs, okay, less than symbol, which performs a bitwise left shift operation. That's what it does. Then we also have the last one, which is going to be the bitwise right operation. Okay. So the bitwise right operation, what it does, it specified actually shifts the bits of a number to the right by a specified number of the position. We will try to look at this like when you have 2 raised power, then it will try to shift it to the right. This in real example. So let's try to look at examples now. We've talked about them and examples of bitwise operation. Why I use the word I comment it, it's going to be easier for tab 9 to know what I'm probably talking about. So now I think this should be out of the comment part. Okay. So now let's look at bitwise operation. We will first assign A to be 10. Okay. Now we now know A, variable A is storing integer. That just like we said, you can store integer 10. Now what we know very well here that is A is 10. But do you know A in binary? Do you know A in binary? Do you know how A is being stored in binary? Let's maybe like say B is 20. Do you know how B is stored in binary? That's why we can use what we call the bitwise AND, bitwise operation AND. Now, when we use the bitwise AND operation, we can now try to see, to check the result and see, print AB. Will it get what I want? If I say print AB, let me see. If it doesn't get what I want, then I'll rewrite the code the way I want. True, false. I think that's not what I want. But let me make it more. I just want it to, let's say we have result and bitwise. So we are doing A and B. Then here we can print result and. I think this is much more better for me. Let me run. So my expectation is that the output still the same thing. It does the true and false, which shows that for the first part of it is a true, because how we have explained it is that the AND operation performs the operation between the corresponding bits. Like the first one, it checks, does it have 1 and 0? Which it does have 1, 0. Now, for the second one, it's not having, that's why it shows it's what? It turns it to 0. That's how it is being stored. But in real time, take time and check out. Know that in binary form, that one, it's written like this in binary form. I think my terminal can't show that, but in binary notation, that's how it is written. Then for 20, probably you check it, you convert it. Okay. All right. So that is being said, this is what the bitwise operation does. And you could run as many examples as possible with different values using all what we have explained. And give me, okay, in form of your assignment, try to run it to using the same example, run it for all this and see if it can, use the O. Let me not even postpone this, procrastinate it, because we can do this for bitwise OR operation and just do that. Okay. OR and just do that. bitwise not, and just do that. Then bitwise left shift operation, and just do that. Then the bitwise right shift operation, just do that. Okay, nice. So we can now run our code and see what it does. You could even make it much easier when you play around with other numbers. So it shifted just like the way I've explained it. So that's what the bitwise operator does. Now we are going to go to our example. I hope that is okay, because I've already explained it. Unless maybe just in summary, is that all these operations, we perform various bitwise operations in them. And this bitwise operation or bitwise operation or exclusive or not, bitwise shift, and bitwise right operations, they are used to help us perform bits operation in form of left to right, right to left, basing on that. So you can try them out in different examples. You will get to explore more about it. Now that I am left with 23 minutes, I'm going to do the first example of building the calculator program, but I will build it without the GUI interface. Your assignment is going to be to build a calculator that can add with a GUI. Just create a simple, it's not a complex calculator, but a simple calculator with a GUI interface. So now we're going to create a simple calculator function. Okay. Function to calculate. I think we're going to do add, subtract, multiply, divide. That is it. So now that we have done it in that way, most of the thing is going to be easier with tab 9. You see, tab 9 is saying that we can define, you see, that's one thing with tab 9. It tends to simplify everything. Hope this is right. Okay. I don't want to have my code like this. Let me write my own code. I'm not going to use tab 9 code. Let me write my own code so that I can debug it easily. Sometimes these codes here, which are, they can make your life very difficult when you're debugging. So let's just add, let's say we are adding A and B. Now we're just going to have two numbers. We shall add, we shall enter using our input. Remember, I explained that we can use input and output. So we can use our input to enter our value. The first, can enter the first value and the second value. So it will return, to get it to return A and B. Then also we can okay. Now we can also define subtract, which can return You know, for subtraction, that's what you do. Then you can still, for multiply. You see how writing code is now easier in. So I think now this is very nice for us because we can define calculator as operators. That is what you want. Me, I want to define it as main. Okay. So what my main will does is it will prompt me to enter 2. Okay. But okay, here you've restricted me a lot. You've said I'm just entering only an integer. What if I enter a floating number? It won't accept because that's what I've told my calculator to do. Because I've said, I've defined that it should just enter only an integer, which can be a little bit annoying. Let's first just have kind of an let's print my just Geoff simple. That's just going to be Geoff simple calculator. You just need to be careful with tab 9 because okay, so our first number is, so okay, let's just call it number. Our first number is 1 here. We just want it to return a float, so that even if you enter decimal places, numbers with decimal points, it should be able to pick up that input. Then our number 2 can be still a float. Okay. Now in that number 2, if you enter any float, it will be able to pick it up. Okay. Now, what operations are we doing? The operations in the input. So the operations in the input is it's to enter operation. We need to deal with it right now. The operation should be, let's think about it. Okay, let's just know the operation. Can use single quote here. We can use the plus and minus and for multiplication the asterisk and the divide. Okay, then let's have all this in brackets so that we can be a little bit safer. Okay, then we can terminate this and leave some. Okay, yeah, that should be able to enter the operation that we need. We just put the plus sign if you're adding. Okay, now still we don't have any error. Now we can use if operator. If operator equals plus result, then add the number. I have no problem with that. I'm going to leave that code the way it is. Else operator and to subtract. elif. Yeah, elif operator subtract. Someone asked me, what is the difference between elif and the difference between else if? Let me write it here. Okay. Let me first write it here. Someone asked me, is there a difference between elif and else if? So they are the same in Python. They are the same, but this is the shortened form of writing else if. You'll find this code when you're writing it using this method is longer. Try to check it out. You'll find it's longer, but they are the same. So just to explain that, has nothing to do. So we have the elif. If this condition is not, it checks this. If this is not that, checks. Okay. So let's have one more elif operators for multiplying. Now we have the one for multiplication. Then we'll need also for division. Okay. Now, what happens else? Print invalid operator. And okay, I think I don't know if it complains, we shall fix the indentation. Okay, we shall use pretty formatter to format our text, our font. So let it return invalid operator. Okay. So let's see. What should be the output now? What should it print? Print result is print we can have else print invalid operator. Then we print the result is, we can try to get the result is, okay, close quote. Let's have a command. The result is, then it prints results. We have results somewhere here. Okay, it's time to comment out this. So yeah, we have the results here. Result multiply. Okay, we're getting some error here. Okay, nice. So hopefully, yeah, hopefully we can now initialize our program so that our simple calculator program can run. So if let's use the advanced annotation to our name, okay, main. Then we can, is the main in quotes? Hopefully, if it is not, we shall get an error. Then terminate that. Yeah, then main turn to 0. So okay. Hopefully this simple program should prompt us to enter the input value, the num that we enter the input value, then basing on that operation. Since we don't have any error, this should be able to work. So let's now run our calculator program, which is going to be Python 3 or Geoff underscore Geoff.py. Okay. 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 It's not running. The program is running. Yes.
The position of your if statement, it's not supposed to be within the main function. The last one, like not that one, not that one.
Okay.
If name is main, yeah.
Okay, let's check it out. Okay, let me just use pretty formatter for that. Okay. All right, yeah. So this is my simple calculator. We can enter our first number. Thanks for checking on that. Now we can put our first number, like let's say 80. Then let's enter our second number, 100. What operators do we want to do? We want to add. Then press enter. So the result is 180. So you can try to subtract, run it one more time. What's the first number? 200. 200. And let's say we want to subtract it with a floating point. Let's say we want to subtract it with 95.5. Enter. What do you want to do? Subtract. So you see it returns the results with a floating point. So our calculator can give even you can divide to get a remainder. So divide let's divide to get a remainder, like 9. 9 divided by which number? By 2. Can get just prompt to enter the division. So it's 4.5. So this is a simple calculator that you can create using Python. Basing on this, so simple code that we have actually created it ourselves. So now, but for you, I want you to apply something called to have the GUI interface. Your challenge is going to be to use, it's called Kinta. Yeah. If you want to have a GUI interface, learn this. Yeah. Okay. So assignment, it's on top of the time. Assignment. So create a simple calculator program with create a simple calculator create a simple assignment, create assignment 1. Assignment 1, create a simple calculator program with a GUI interface. Make your title, of the calculator program make the title of the calculator program with program window with your name. E.g. Geoff. Okay, I think Geoff, I know you will figure out how to do it. Geoff, simple calculator. Okay, that is it. That's your assignment. Yeah, I know, but perform these operations: add, subtract, multiply, divide. Don't go too okay, you can go complex. Okay, you can, let me, since you're submitting at midnight, I don't need you to go complex, because we have people learn in different ways. There are people who are conceptualizing it faster. There are those who are slow. All the brain is not the same. Let me just keep it this, but I could have gone complex and allow you to build a scientific calculator. But this is just a basic calculator. Otherwise, thank you for tuning in, and thank you for being wonderful students. And I hope I'm laying a good foundation. One day you will remember me. You won't splash water when you're driving your car after bagging some serious jobs. You will greet us, me and Dr. Ruth. We will be waiting in future when we are old, sitting somewhere in our garden. Yeah, we'll be receiving your calls and you sending us some goats, and you know, we'll be chilling with it in our farm. Okay, thank you. Over to you, Dr. Ruth. My journey stops here for today. It has been a wonderful session.